This video covers everything that we did in class today on Monday, February 28th. To follow along with this video, you will need to have ClassKick open as well as the video in two separate tabs. On the first slide of ClassKick, you'll see the announcements that we went over today. You can pause the video to read or open up ClassKick and read within ClassKick. On the second slide, you will see the learning target for today. I can find a solution to an equation by reasoning about a tape diagram, about what value would make the equation true. And then on the third slide, you'll see the first place where you need to do work. That's today's do now. So go ahead and pause this video, go through slides 1, 2, and 3, and complete the do now. When you're finished with the do now,
please come to the front office for dismissal. Marquise Floyd Reed, please come to the front office for dismissal. Thank you.
when you're finished with the do now, please come back to this video.
Hey,
Hi.
are you busy?
Yeah, I'm recording. Sorry.
No problem.
In question 1, you can see that we've taken our original equation, 20 plus 14, and created the equation in factored form. 2 is a common factor between the numbers 20 and 14, meaning that 2 can be multiplied by another whole number to get 20, and 2 can be multiplied by another whole number to get 14. Notice that if we were to use the distributive property, 2 times 10, we would get 20, and 2 times 7, we would get 14. We're simply working in the opposite direction this week. So, for example, when I have 35 plus 50, I know that a common factor, a number I can multiply by to get both 35 and 50, is 5. I know that 5 times 7 is 35, and 5 times 10 is 50. And so I can rewrite my equation as 5 times 7 plus 10. That will get 35 plus 50 if I were to distribute. I can do the same thing in question 3. A common factor between 22 and 33 is 11. And so I know that 11 times 2 is 22, and 11 times 3 is 33. In questions 4 and 5, my work changes slightly because now I have variables. I know that I am multiplying x and y times 2, which means I can pull the 2 outside of my parentheses and multiply 2 times x plus y for 2x plus 2y. I'm multiplying 2 times both variables in my expression. Finally, in question 5, I know that the common factor between 10 and 20 is 10. And so I can multiply 10 times x plus 2y. The reason why I'm multiplying times 2y is because once I distribute my 10, I want to end up back at 20y. 10 times 2y is 20y, and that's again why I have 2y instead of having simply y. The equations on the left side are written in distributed form. They're the equations where we've already used the distributed property. The equations on the right side are written in factored form, meaning that we've pulled a factor outside of the parentheses. This will be our foundational learning target for the week, and you can expect a quiz coming up on Friday. Let's take a look at today's main lesson. The first thing we did today was a number talk, which you won't be able to participate in if you were absent from class. But the key part of today's number talk was recognizing that when we see the phrase solve each equation, what that means is we are finding the value that we can replace the variable with to make the equation true. So here's an example, right? If we have x minus 1 equals 5, I know that x has to be equal to 6 in order for x minus 1 equals 5 to equal 5. Things get a little bit more complicated in a situation like question 2. But I know that 2 times some mystery number equals 10. That mystery number, of course, is 5. 2 times 5 equals 10. Now, where the 5 would be, I have x minus 1. And so I know that x minus 1 has to be equal to 5. which means that x must be 6. So that when I multiply 2 times x minus 1, I end up multiplying 2 times 6 minus 1, or 2 times 5. In the rest of our learning today, we'll be looking at solving equations that involve tape diagrams, and that should feel a little bit more familiar. Meet me on slide 5. Slide 5 says, draw a tape diagram to represent each situation. For some situations, you need to decide what to represent with a variable. Question 1. Each of 5 gift bags contains X pencils. Tyler adds 3 more pencils to each bag. Altogether, the gift bags contain 20 pencils. I'm going to start by drawing the core pieces of my tape diagram, which of course starts off with just the one long box. I know that in this situation, I'm representing the total number of pencils that were gifted to Tyler. And I know my box is a little crooked, but it'll do the trick. Altogether, the gift bags contain 20 pencils. And so I know that I'm going to label my tape diagram with 20 in total. I also know that I am buying or creating 5 gift bags, which means I'll need to split up my picture into equal groups of 5, because that's how many gift bags are being created. Now, inside of each gift bag, 2 things are happening. First is I know that there are X pencils inside of each gift bag. And so within each gift bag, I'm going to go ahead and write an X to represent the X pencils that end up in each gift bag. X pencils. Now, the other thing that's happening is Tyler also adds 3 more pencils to each gift bag. And so in addition to the X pencils in each gift bag, I also need to add 3 more. And so I end up with X plus 3 pencils in each gift bag. And that's all I'm asking you to do today, is simply to create the tape diagrams that represent these situations. When you're finished watching me do question 1, your task is to create the tape diagrams in question 2, and then on the next slide in question 3 and 4. If you were absent, you can skip activity 5.3 and just focus on creating the tape diagrams for now. We'll come back to the other parts tomorrow. On slide 7, you have a summary of today's lesson. Once you've finished answering questions 2, 3, and 4 on slides 5 and 6, you're all caught up. As always, if you have any questions, please make sure to send me an email.